everyone. Thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Shirley Wu, a PhD student at Stanford University. Shirley is absolutely at the cutting edge of artificial intelligence. She's published a ton of amazing papers and is currently working with Yuri Leskovich and James Zhu at Stanford. In this podcast, I really want to dive into two works that have had a massive impact on us at Weaviate and the things that we're building, the Avatar Optimizer and the Stark Benchmark. But before any of that, Shirley, thanks so much for joining the Weaviate Podcast.
Yeah, thank you so much.
Awesome. So I'd love to ask you this kind of question. I know kind of diving right into it out of the gate, but I'd love to just hear about kind of like your perspective on the state of AI and maybe just like kind of, like sort of your world model that is shaping these papers and just,
Oh, yeah. I think for Avatar, it's like at first when we are thinking about like doing an agent for a specific task, it's actually a follow-up work for our like benchmark paper, which we will go into later. But at the time, we are thinking, okay, now let's say in a general setup, we have some user queries, and why not just like implement some tools and ask the agent to do the task. So we like did everything, including prompt engineering. We include like very good tool description and so on, and it just didn't work. So it's very disappointed to see like the agent is actually not use the tools properly. Like it kind of missed some key information in the queries and so on, and that's kind of how we are motivated to like dig into more about like AI agents and the avatar.
Oh, awesome. Yeah, I think we had the same kind of, like I was a huge fan of the Gorilla LLM from Berkeley. I still am. I'm like actively working on it. I just love this idea of, like you say, benchmarking how well it can use the tool and whether that means routing across different tools or, like formatting the arguments for tools, especially like, I think we share this interest in database querying as a tool, and it's like using the right query operators and all that kind of stuff. So maybe even before we kind of unpack Avatar a little bit and how it optimizes agents to use tools, I kind of want to touch a little more on Stark and kind of your perception of data models, because I've been following Yuri Leskovich for a while with things like Kumo, and so there's kind of like this perspective on like a relational. It has like this graph. Like I understand you've done a lot of amazing work on graph neural networks as well, and so I'd love to maybe just understand further that perspective on like this like relational data model, but it's like a graph, yeah.
Yeah, I think it's very interesting. In that work, I think in the past we used to have. I think in the traditional machine learning, we used to like just clean up the data as clean as possible, right? We have this like data table. We have like different features. We like do normalization in each column, and I think at that time the key idea is that we want the data to be as good as possible so that our traditional machine learning model can learn well. But nowadays, it's like kind of the opposite way, where we just want to present the data as what it is. For example, in the like real world, like people are connected. It's a like social network, or items they are connected, and even like in the biomedicine, a lot of like for example, drug can have relational information relation about like connected to like other entities like protein and so on, right? So essentially, like the world is interconnected, and moreover, in each entity we have our own description. So I think the key idea of avatar is like the data is constituting this world, and we are just want to present this like realistic data schema to the LLM or whatever like AI agents there for they to like explore this data schema and for they to like learn from this data and just explore this world by themselves.
So with our experience at Weaviate, we're pretty familiar with kind of like representing objects with a vector embedding that encodes each object. And is my understanding correct that maybe the idea is, so I have my vector embedding for the description of an Airbnb listing, and then I might have a relational edge to say like the city that it's in, and that city would also have a vector embedding. And so it's kind of like you've created like this attribute graph where each of the attributes or like a value that a column might take on, like you have colors like blue, red, green, it has embedding for each of these colors. So you have like a graph where embeddings of each of the attributes kind of like flow
Yeah,
through the graph.
exactly. Yeah, so basically you could have the like the individual representation for each node in the graph, and then you can just like kind of, and you can also like do message passing. For example, like the connected nodes would have similar representation. And I think this way, like, you see like rows representation kind of like merge into each other, and you could learn like rows kind of like relational information from their representation, and it will be like very useful for any kind of prediction. So for example, a user may have a query saying, oh, could you recommend me a Nike shoes with like cute design? And like if we just like read this query and think about like how people used to generate the recommendation, and one typical way would be I would just embed this query into an embedding, and then I have the embeddings from the graph from each node, and then I just compute the similarity between them. But it would be so much easier if we could actually go to this graph and find the node called Nike, and then just trying to explore its neighbors, which are products on the Nike, and it will be like so much accurate. So I think beyond the representation learning on graph, there's also like a more flexible design to like explore and like get better prediction results.
Yeah, so I think like this, yeah, like GraphRAG is maybe like the buzzword thing that
Yeah,
people are seeing, and I love the way that you combine this kind of like, so you might vector search to find the node, and then once you have the node, the like RAG thing is you then expand the neighbors, and you kind of like give all those neighbors as context to the LM and the RAG kind of thing.
yeah,
Is
you can
that?
kind of think of it as like some channel dot reasoning, but on graph. So
Mm.
we kind of want to break down this query into like multiple parts, and then we do like reasoning on graph instead.
Yeah, could you maybe just like zoom into that a little further? So once I've got my node and now I have the neighbors, is now the LLM tasked with like it has the actions of which edges it wants to follow. Is that a correct
Yeah,
understanding?
yes, yeah. So I think in the word like if we are gonna like solve this problem with AI agent or even with human, let's say like we are given this large graph and then we are gonna look into graph by ourselves. And I think this is the most like reasonable way to do that. Firstly, to like basically reduce the search space to a very like small number of nodes. And then we are trying to do like more precise filtering, and of course like we could not like say there's also one more requirement right in the query saying, oh, it should be a Nike shoes with cute design. So we are looking for shoes and cute design, and we are gonna like read those Amazon reviews by the reviewers to see whether they actually have a cute design, and or yeah, whatever we understand cute it is. Yeah, so but we have like better tools to do that. We can like just use I mean, search tools or Control Plus app, try to search for those keywords, and this is the most like sensible way to do that.
Yeah, super cool. So maybe we could just kind of keeping on this path. One of the quotes from your paper, that a Stark paper that I really liked, is about how people are mostly kind of studying like textual retrieval and then relational retrieval as like two totally separate things. Like the search engine has like this structure of, yeah, just like kind of one property that has the document and they're just kind of all indexed, whereas relational retrieval has like this text SQL type kind of structure. And can you maybe just further explain like your view on unifying textual and relational retrieval?
Yeah, for sure. So I think let's take an example. So I think what the traditional relational retrieval can do is that they are very good at answering the queries, such as let's give me a shoes from Nike. It's very easy for them because they are looking at this table data. They look at the brand and it's, oh, just filter the Nike shoes. But it's tricky for them to understand semantics information, such as Q design. It's very hard for them to encode that. And on the other hand, in the retrieval system, like what I mentioned, if we are just getting the entire representation about the document, a product, then we are trying to fit them into a fixed size representation, which will cause like information loss. And for example, even like the some user mentioned like some small details like, oh, cute design and my cousin like it very much, but this is a very like long document, and the information would just lost in that embedding, and we would it's very hard to find it, and it would like even confuse this embedding with like some other description. For example, oh, this is very durable, or even in like this document, even the brand is not Nike, is for example Adidas, then embedding the entire document would cause the information loss, and this would just make the recommendation very imprecise. And I think if you go to Amazon and trying to search for example, just try like Nike shoes, and then sometimes it give you like shoes of all kinds of brand. Yeah, I think that's the problem that we want to solve.
So I think on that, I guess I have two things. I'm in my head of which question I want to ask you next, but okay, so I think I'm going to go with this path of asking about this kind of like multi-vector perspective. So something that we hear about all the time with like building search engines is like people have an embedding for the document text as well as like the title. So you have you obviously like chunk your text for vector
Yeah,
databases. Yeah, and then you'd also have a vector for say the title. So you have like multiple vectors to represent
yeah.
each object. Is this kind of like
Yeah, it does help. So yeah, I think it basically alleviates the concern that I just mentioned before, and it kind of prevent the information loss. But sometimes it's still like cause very like imprecise retrieval, and we did have like a baseline implemented in our paper shows that it seems like this multi-vector retrieval method is very good at improving the recall. It's good at like gathering like all relevant answers, but still if you look at the hit at 1 or hit at 5, it still like lost a lot of like correct answer. So I think it's about like how do we leverage the reasoning capability, and I think that's the truly amazing part of LLM, which is it's good at reasoning, and we are not supposed to just like use it as like some embedding model, and it's just like oversimplify their capability. And that's why we are going to in that path that it can actually read the query and trying to analyze different components and do this like more discrete but intelligent actions to complete the task.
oh I think like there was like this big thing about like ranking expressions in search where you'd have like these funny like boost this particular keyword times two if it appears, and like so you'd have all these crazy ranking expressions. Do you think maybe we'll see like the rise of ranking expressions but with multiple vectors per like column? Is that maybe the right way to think about it? I don't.
Yeah, I think yeah. I think that also touch on the problem of scalability because like
Oh.
once you cut them into say like 1,000 pieces, then I suppose you are gonna like save them to somewhere or something. And also like every time there's a new query coming, we also need to compute the similarity between like the query embedding and or like rows like a few thousand embeddings, and that could be pretty expensive. Yeah, I think.
So with scaling it, I guess so that's also kind of so I guess I'm also kind of thinking now about like the scaling of structured attributes and yeah, just how you think about that because I guess I could like extract an arbitrary amount of structured things. Like if we go back to our Nike shoes, it's like I could say the color, I could maybe say something about the materials, and then maybe I could even zoom in on materials and make all sorts of additional categories about that. So I'm kind of curious how you think about just the structured attributes that we use to define our data and just yeah because I guess that's also like a sort of that's kind of like the thing like embeddings kind of like capture all of these structured attributes, but it seems like you also have this like relational graph perspective. I'm still trying to wrap my head around it to be honest, but
Yeah,
like yeah.
but yeah, I think too. This is actually something we thought about at the beginning, where we can just like trying to extract the attributes and like construct a large table for the for the model to train on. And it's hard because of two things. One is that we have no idea like because the columns are manually designed by human, and it's very possible that we may lose some attributes, and the attributes may not be like just uniform over all the instances. For example, for the shoes, we can say, oh, it's material and so on, the color and so on. But I guess like for some other items like plant, then yeah, we cannot like easily describe their material. So there's like this I think kind of like heterogeneous columns there that's spread across like different products, and then they have like different dimensions that we want to pay attention to, and it could be a large, very large table as well. You can imagine, I don't know, like maybe millions of attributes there, and that requires manual design. So I think that's one thing. And the other thing is, I think the data nowadays are like they're evolving, and there's like new attributes coming in and out every day. For example, some products may just out of stock, or they have like no like red version of in the shoes, and you just need to update this like table constantly. But if we just like keep the data as what they are and trying to like do more flexible reasoning, and it would make our life so much easier. Yeah.
So I guess maybe connecting back to that, yeah, the color example helped a lot of this click for me, and kind of the question I want to ask you, which is like, I would hope like the world's best embedding model would be able to look at a Nike shoe and sort of contain Nike in the embedding rather than needing an attribute that says Nike. Like it's just seen the internet, and so it can tell the visual style. So I
Yeah.
guess that's kind of where I'm at with this, is trying to understand like when it's just always captured in the embedding, or when you need to add the structured attribute. But then I think like when you have things like you mentioned, it being out of stock, there's also these like attributes that are like totally unrelated to the content of the item.
Mhm. Yeah.
and, and then I'm confused about how, yeah, just how you might think about flowing, like, because if you have this graph, coming back to the data model, I think, where we have these edges that are like about attributes, like if it's out of stock, then
Mhm.
like so how might you combine the database structure of yeah, does that make
Yeah.
sense? Yeah.
Yeah. So I think for the like Nike example, actually we could also to like basically build a representation for that. We can also have a node in our graph that says yeah Nike, and this Nike could like basically we can learn its representation from like its connected products and so on. So I think that's the first thing. And about like this dynamic way about like having the attributes on the edge, yeah, actually we can model that. And even like on the graph, it might basically on the GNN it would be embedded as like some edge embedding, and we could also leverage that to do retrieval. And also it's interesting to like think about more like hierarchical searching perspective, where we have this like original graph, right? But it doesn't mean those are like or we have all this embedding, but that doesn't mean those are all the informations we have. Once we have, for example, do a retrieval on a like very high level, once we locate it or we want the Nike shoes, then we can look more closely at like the those edge attributes, and we could like even change our embedding methods to get a like best way of retrieving information. For example, like what you said, doing like this like multi-vector retrieval, and this will be more scalable because we start from like fewer embeddings to like more detailed and precise embeddings.
Yeah, awesome. I remember Cohere. We had a podcast with Nils Reimers, and they were building something called Compass, which is kind of like this embedding strategy that had this like attribute graph. And I guess maybe I don't know if this is. Sorry if I'm just restating what you just said back to you for my own understanding. But like if I might have an embedding of the picture of the Nike shoe, and then
Yeah.
I have like it has the attribute of its price, and
Mhm.
let's say it's initially listed at $200, and then maybe like as time goes on, it's discounted now to $120, and like or like however many, but like somehow this discount is like comes back into the representation of the shoe image because of how it's all connected. Is that
Hmm. Yeah. So I think that depends. In ground neural network, if you set the message passing to like the number of hop to be one, then so you have the shoes here, then the shoes connected with the price, the shoes connected with the image. Then the this message passing will only affect the shoe itself. It won't be passed to the image. And I think yeah, it's very interesting to think a more like multimodal graph. And yeah, so I think for the like ground neural network is I would say it's very like powerful. And But in the other way, it's good to like think about the data structure and the best way to like learn rows representations in the graph level. Yeah.
Yeah, I'm maybe biased by being at Weaviate and being the Weaviate podcast, but you're making me more and more excited about vector databases because I'm thinking about the. I know that's probably pretty biased, but that the idea that like vector like that the database can have in computing the embeddings in this kind of system. Does that sound like a right? Like because the structure is so involved in updating these embeddings, it like the task of managing and updating embeddings feels like so much more involved for like the database system.
Yeah, exactly. Yeah. So I think the database system now we could have I think even in the star paper we only consider like this textual and the relational information, but it's getting us very excited to think about like more different like multimodal data, including like the image, even like audio, and like how we could get better representation of them, and especially like across different modalities is very exciting. And I think Voyager AI actually does that too. So that's pretty relevant. And I think from database perspective, I feel like nowadays everyone, even like for the in the user level, everyone have like their own small database, and not to mention like large companies like I don't know CZI. They have those like connections with patients and so on, and it's make a lot of sense that they have a much larger database. And we also like collaborate with some external collaborators, and they do have this strong desire to make LLMs work and customize to their own large database. So I think that would be some very exciting future direction.
Yeah, amazing. And so I know that we are kind of going pretty deep into the kind of data model perspectives in Stark, and I definitely want to like kind of for our podcast listeners do a deep dive into Avatar. So I have one more kind of question, and then we'll maybe unpack Avatar about the data models and this relational structure. Is so I understand that PrimeKG, I think this is a knowledge graph that I think comes from Harvard Medical School as well as Stanford. And my understanding is that it's like the world's most like advanced sort of like medical
Yeah.
knowledge graph. So how, yeah, can you maybe just tell the story of Prime KG and just like I understand it's like diseases and genes and things like this.
Yes. Yeah. Yeah. The PrimeKG is actually the work from our like co-authors in the staff paper, Cousin, and I think they are trying to combine basically the information from different knowledge base. So I think in the bio there are a lot of like segmented, for some reason segmented knowledge base there. For example, like a drug bank and Unipro. So Unipro is a like protein database, and drug bank they have this nice description about what like each drug does and um, their functionality and so on. But they are very segmented. And as I mentioned before, the world is itself interconnected, and there are like so many like so much experimental data about the how they are interacting with each other. For example, protein and protein they can like interact with each other, and even protein and genes, and also like drug and the disease and so on. So basically, that work is trying to combine the data from all those like public source together, so we have a like more global view of this like scientific knowledge and how to discover biomedicine like discovery. Yeah. There.
And so I guess then from that I'm just curious, yeah, about like so I love this phrase precision medicine. It kind of offers this promise of using all this data stuff for our healthcare, and so I guess I just love to understand like how you see like I've done a little bit of work with electronic health records to understand how you might represent like how typically like say I would be represented in this like tabular structure of like my gender, my age, my if I'm a smoker, things like this, and then so I'm curious just if you could explain how like, patients are being represented and then how relevant information from this prime KG graph, like how these things are coming together to, yeah, like I guess perform that like GraphRAG, if we will, of that, like,
Yeah.
like, yeah.
Yeah. So I think, yeah, that's very interesting because I think in the patient profile, including the age information and the description of symptom, some of the information are actually very relevant to do like precision medicine, because for example like for example they are like symptom but sometimes not about their age. So I think in that space it's very important to select the feature that we want to use, and especially we have some like causal understanding about like how the this condition could be corresponding to a certain disease. Then we will try to like make sure this model is not biased towards certain attributes like age. I don't know, maybe like there's some disease that everyone could have no matter what
Oh,
their
wow.
age is. Yeah, so and I think in the medicine domain there are also adult information a lot like spatial method that we should invent. For example, in the like patient's record, electronic records, sometimes like for the doctor side, it's like they would need to write a very long note about this patient's like symptom and so on. But a lot of them could be like say summarized by language model nowadays, and only like key information would then the doctor would just take time to do some like key reasoning, and then trying to search for like more information in, for example, this knowledge base, and that could make sure the diagnosis is correct. Yeah.
That's amazing. I've always I've been trying to understand causal inference. I'd be lying if I said I did understand it, but I understand a bit that you have these like causal pathways, and you try to like identify
Yeah.
confounding to like reweight the pathways, and this idea that that's what you're using the graph for, to use kind of like patient as search query to then bring the graph and then like debias potential confounding like
Yeah. Yeah.
conclusions. Yeah, wow. So yeah, so congratulations on that. I think it's so amazing just to follow along with. So I'd love to then transition, and yeah, so maybe concluding about Stark. I think it's such a powerful benchmark. It's so cool how you have these kind of like three levels of like this medical knowledge graph, and then like the Amazon products, and then also kind of the scientific literature. I think these are just super awesome three applications to be framing a benchmark like that. And yeah, I love the textual retrieval, relational retrieval, unification. All that is so awesome. But so maybe coming into people just kind of building more everyday agentic RAG systems. I'd love to now kind of unpack Avatar and dive into. So we opened up by mentioning that the idea of Avatar is, so we have all these. If has to do, Shirley, how do you see this kind of like prompt optimizer story? Yeah, and then maybe contextualizing Avatar within it.
Yeah, so yeah, I think at the time our focus is more on the tools, and I think nowadays we have like already a very well pre-trained large language model that knows like both general and the web scale knowledge, but we also have like a specific task that we want the this LM to adapt to. And in that space, for any like complex task, that would involve like tools, and that's why we are trying to give a couple of tools to the LMs, and trying to that this agent to reason about like what kind of actions to make and so on. But yeah, the initial motivation is that we see like very bad results. We are actually implementing the agent for the Stark benchmark, and just trying to like navigate and explore the graph and get the correct information, and retrieve the right entity like the shoes. But actually, when we did that, and we found that the performance barely outperformed like a very like simple dense retriever, which is very surprising because we tried like all kinds of stuff like prompt engineering and in context learning and so on, but it just like didn't work. So we kind of go into the direction that maybe it's not some problem that can be solved by zero shot vision of the agent. Maybe there's like certain optimization that we need, and especially important about like how to teach the agent know how to use like some tools that it never used before. I think that makes sense for human as well. Like yeah, I think like when the kids playing toys and or use some tools, they may just try a few, and after they did that, they always have their favorite. Like they have this prior knowledge about what to use after like initial exploration. So yeah, so we do think about or regard the agents as human, and trying to think like how the agent could be possible to adapt to a task is very important, and that's why we go into this like prompt optimization and essentially teach the agent to do a task.
Yeah, so one part of this that's really resonated with me is so with our Weaviate formatting our query APIs as a tool, you might have a text property filter where you want to have it match a keyword compared to a search query, and our just zero shot our models can't seem to tell what the difference between a text filter and a search query is. So
Yeah.
is this kind of so then this kind of like contrastive perspective on it. I mean, I think when contrastive learning hit deep learning, that was already such like a and it created embedding models and such a representation learning breakthrough. Yeah, so maybe if we could further come into like contrastive prompt optimization and how that differs from yeah.
Yeah. So I think the high level idea of the contrastive prompt optimization is that language itself is very ambiguous. So let's say you have an article and you ask like a LM Judge or like GPT to summarize it or like evaluate it, and you will say, oh, it's very creative, the grammar is correct, and so on. But then you have no idea whether it's really good or not, right? So we always need like a certain comparison to give to the language model. So it say, oh, compared to the other article is maybe that's creative, and the other article is apparently better. So I think that's the first intuition. And the second intuition is that there's a, like an analogy. I think when people are training like deep neural network, we barely set the batch size as one. And even nowadays, we are training this large language model with very small learning rate. We also do like gradient accumulation. So I think the insight there is that if we are trying to just update a model or agent on a specific instance, the gradient itself, or the textual gradient that we want to influence the prompt would be very unstable. So that's why we're trying to basically have this mini batch and like more observations for the agents to learn from these observations, and then it could update its prompt towards a more like generalizable way. So I will give you one example. The key insights of avatar is like, let's say we have a batch of user queries as input, and then initially the agent may have a action and like an action sequence that can be applied to each one of the query. So if we just like execute like each this action sequence in each query, then two things could happen. One thing is, oh, we get the correct answer for this query, or we didn't. So in that case, we can just like split this batch of query into two parts. The positive one, which means that the current action sequence can already does well on them, and then the second batch, which is the opposite way, they didn't like good get very good performance, and then we give these two batches of query to the avatar agent. And an example could be the positive query might be the like simple queries with like simple feature mentions like, oh, red, cute designs, very durable. They are very simple in terms of the format. But the negative query could be more complex. It could mention, oh, yeah, I need shoes from this brand, or I need like, I don't know, a new jacket that match my pants, or yeah, I want like something similar but like more like cheaper than my previous purchase, and so on. Those are complex. So once you give this two batch of query to the agent, then you would understand, oh, maybe the current action sequence, it failed to handle those like more complex queries. And for example, it missed this relational information. It missed to do like more precise keyword matching based on the brand and so on. So it would be, this is like a very, I think, powerful design, and we actually see the in the experiment about like how this contrastive prompt optimization teach the agent to do like better task decomposition, like how to split the query into like multiple parts and process them individually, and also about how to use tools like the agent would reason about, oh, actually you shouldn't use like this string matching here, it causes like this zero rewards, and you might want to switch to like more for example embedding based matching, embedding based similarity. And yeah, so it's very interesting that about this like contrastive reasoning, and then how it combined into the prompt optimization.
Yeah, it was an amazing explanation of it. I think I've already yeah gained such a better understanding for it, and so I guess yeah, so I love that perspective of you separate it into like high reward. So you still have some kind of like LLM as judge, or maybe you do have like a rating for your task, and then you separate the
Yes,
performance, and
yeah.
you
So there's a metric that could be used to separate.
yeah. So I guess I want to ask about so the Opro prompt optimizer has this kind of like evolutionary perspective where it's looking at say 10 prompts and then their resulting metric, whereas Avatar. And then Oprah is just going to try to like say what's the best part about each of these prompts that's getting us to the
Yeah.
so does Avatar also have this kind of like global view of um like these perform, but then it also has this bias of like we'll contrast it particularly 'cause- yeah. So-
Yes, yeah. So I think in our design, we got a lot of inspiration from Opera, and I think the kind of this advantage about Opera is that it kind of look at the, it kind of like what you said, have 10 prompts and know their corresponding performance, so that can like just trying to select the best one or trying to evolve into the better prompt. I think we have a also have a like similar design in the avatar, that in the sense that it's like an evolving process, and there are like different copies of prompt, and once you have that, it's up to you, like you can just try to evaluate the prompt in some like evaluation data set, and then you can just select the best prompt across the training. So I think we have the similar concept as opera, that we are trying to look at those evolving prompt and select the best one. But the key direction that cause the prompt to evolve for us is by this like contrastive reasoning, and based on this training data and how we sample those mini batches, and then the agent will just trying to um, gain better performance on the negative queries, and that's why yeah, how to make it go to a better direction. Yeah.
Yeah, that's so cool. I think yeah. So then I'm curious about this kind of like preference optimization thing. I guess like that's one way to kind of like self-supervise all tasks is you can kind of flip any two model responses into kind of like a contrastive, like this is good, this is because it's better than this other system response. Does preference optimization, does that kind of naturally fit with the avatar
Oh
contrastive?
yeah, I think yeah, it's pretty similar. I think the difference thing is we are looking at the same action sequence. So this action sequence, you can think about it as like the parameter of a model. It is fixed. It's generalizable for like multiple queries, and we are looking at its effect in different type of query. So the I think the high level thing is that instead of asking the agent to reason between between different features, we want it to reason over different patterns, and this is the pattern the most important thing for it to go to a better direction. And I think in the like the preference, the reward modeling, where we have two models and they generate like two different response, and we are trying to rate them, yeah, it's I would say it's very similar, because like both are trying to look at like different cause and effect. Like for us, it's like we look at the action sequence. Oh, it causes like different effect on
Mm.
different queries, and then we are for the two models set up. We are looking at, oh, two models have different generations, and these two cause like different rewards for a certain task. So I think yeah, it's very similar in the sense that we are trying to have this like contrastive or comparative way of modeling.
Yeah, wow. So then there's also the MIPRO idea, which is like yeah, I guess it's so the MIPRO is like, let me look at the data set, then let me look at the prompts, and you're kind of like combining all these breakdowns. So would Avatar maybe like break down contrastive explanations of the prompts and then try to like aggregate it later? Like maybe I look at two, oh sorry, so action sequence. Sorry, I'm mixing up the prompts and the action sequences. So I might look at these like two action sequence or a big batch. So sorry, I'm like mixing together so many ideas, but like this so it would look at a big batch of successful action sequences and unsuccessful action sequences, and it makes some observation from that, which it uses to update the tool description. And then where does like kind of like the hill climbing sort of like um, yeah like so then it updates the new prompt, and then you get another action sequence.
Yes, yeah, exactly. So basically, I think uh, you can think about the avatar as like a self improving, but if you want to like split up, there's actually a component, the actor which produce the action, and the second component, the comparator, which teaches or generate the instructions to give it to the actor agent, and it would like trying to do better action. So in other way, the comparator is trying to generate better prompt for the actor. Yes.
Oh, amazing, awesome! I think I got it now. Sorry, my brain just
No
trying to
problem.
wrap my head around it all.
Yeah.
But yeah, awesome. So yes, I think it's such a powerful way. I mean, I love. So I guess I kind of want to ask about the. I mean, so contrast this kind of contrastive perspective on prompt optimization. It could be more broad than just tool description. Like it could just be any task, right? But
Yes. Yeah. Exactly.
yeah, very cool. Awesome. So then there's one more part to your papers that I wanted to talk about, which is this task of complex retrieval. I think we're seeing a lot of like compound AI systems agents that like at Weaviate we've definitely like explored the question answering like in the chatbot, and then I think like report generation and like deep research, that's maybe the hot topic right now, and things like the Storm system from Stanford. And but so there's other task of complex retrieval where you might have another great example for this is like re-ranking models with LLMs, where you could have like LLMs to re-rank. So I guess I want to understand your perspective on applying these agentic architectures, compound AI systems, to this task of complex retrieval, and yeah, I guess just like generally how you see that. Yeah.
Yeah. It's very actually very relevant to what we are doing right now about like the component AI agent systems, where we want to have where I think the assumption is that for easy tasks, it's just very hard for like one LLMs to reason and get the results, and that's why we want like specialized agents in each step. For example, one agent could dedicate it to like understand the user intents and break down the query, or and the second agent could just like do retrieval, and or you can have like multiple agents to do retrieval. One do like more a high level retrieval about like the product type, and then the second do more fine grained retrieval on the like particular keywords, and just like look at the detailed information in the document. So it's very exciting, and then there could be like a last agent doing some re-ranking and make sure the answer is correct. And in that space, this is I think the it would I think the multi-agent systems are on the rise, and it's actually make the task itself so much harder, because sometimes people just look at the input and output, whether the input cause like a good results in the output. But nowadays you have like more and of course powerful system, and there are a lot of like intermediate results that may be broken and you are not aware of, and that would require a lot of optimization. And we are trying to build basically like automatic optimization system for multi-agent, and I think that is very exciting for us.
Oh, wow. So the multi-agent perspective, is that so relating to retrieval? Might it be like we have different like retrieval tools, and
Yes. Yeah.
I give it the query of find me like a I don't know, like a low calorie energy drink or something. So they each,
Yeah.
e-
Yeah.
yeah.
So I think, yeah, in that aspect, I think basically different agents go beyond just simple role playing. I think in our specific setup, we don't just like want diversity, different opinion from this agent. talking to each other. Instead, we want like those agent, each agent to be specialized to their own task and know like, they have a different copy of prompt to or different set of tools that they know how to use best, and then they would just like collaborate together and doing this task in an end-to-end fashion.
That really motivates me to want to ask you about how you're defining agents, because like I'm curious about, yeah, like it sounds like you're on the an agent is like an inference with function calls as an option, so it's kind of like function calling agents glued together. Is that, yeah, is that
Yeah, I
mostly?
think the term of agent probably don't appear before LM. So I think the traditional concept of agent is very different from the our definition now. But for me, I think my definition is that agents equals to LM plus complex tool usage and maybe a multi-step task. Yeah.
Mhm.
So yeah, so I think it would be really like important for like those agents, not just of course, like output generation is a type of action too, but
Oh yeah.
the way we think about like agent is more about its capability to deal with like complex tasks and like just continuously to reason and think about like how the agent would maybe cause some change in the environment and then it move on to take another action. Yeah.
So that then motivates me to want to ask you about so when you have the function, I like to call this function calling, if you'll allow me to call
Yeah.
it. Yeah, yeah, okay. So when I'm calling my functions, like I do for retrievals, and now you start to have this like intermediate memory. This has led me to just really love memgpt and letta, and I'm really
Mm.
interested in that kind of like you have like a meta prompt that's like, hey, token windows at 4,000 tokens, we got to move some of this to our internal memory database. And so how do you think about that, like working memory of a function calling agent as it's going
Yeah.
through its yeah.
So I think yeah, that's very interesting because at the time that when I was thinking about the direction for a project, we were thinking about like how to better innovate the like memory bank of agent, and so there's like I think two opinion. One opinion is that with the context sense of LMs becoming longer and longer, maybe we don't need a memory bank. Maybe we can just put everything in the context. And yeah, that's one opinion. And I think the second opinion is that with the it's very I think it's about the problem of scalability, and we just could not put everything in the context. It's far too expensive, and also like building a better memory bank, not just putting everything in the context, would be more targeted. So you could think about like the agent. There's some experience. They're given a task, then it maybe it does the task very well, and we store that trajectory, that the action in the memory bank, and next time maybe we can just like do retrieval, and given a very similar query we can just like retrieve that particular successful action and trying to include that in the agent's context,
Ah,
and maybe you would like learn better. So I think memory bank is very interesting, and you can just think about it as like a database. We are building a like personalized database for the agent, and it contains like all kinds of knowledge that it can use. We can even like build the memory bank like similar to like a graph. It could be like a relational, and there could be also like a lot of textual information, and I think even like some I think useful from for the agent to use. So it's very interesting about like how to build a personalized database or like memory bank for the agent. And I think a lot of cool design could be involved there, including retrieval, including these different search strategies, and including like some key technology that we innovated for Stark as well.
yeah, amazing. I think I love all these ideas. I think it's such a compelling vision. I guess so I wanted to ask about okay, so you have this agent work. I like to call this agent workflow memory. I think there's a paper from Carnegie Mellon that had like called it that, and it just always stuck in my head. And so like for me, I'm always between like I love this idea of the function calling agent that's got, it's got its self-editing memory, it's got its internal database, and then, or you have this kind of like flow engineering compound AI system type of perspective where you've like hard coded the workflow in advance, and then you can kind of like optimize that particular workflow. But then I think about like for me and like Weaviate, when we're working on our agents project and we're trying to like design our agents, it's like, okay, what would be the step of inference? What would be the workflow? It's kind of hard to just like manually design it. So I think about a lot about how this agent workflow memory can help you kind of mine out the workflow. But then I'm still a believer that once you have the workflow, then you can give it to like DSPy and use the avatar optimizer with it, and you can optimize that like four step process.
Mhm. Yeah.
So
Yeah, exactly. Yeah. So I think it's about the like problem of how to decompose the task and how do we construct the agent system. And I think this is really an pretty cool and also like open research question. So for example, if let's say we have a task about writing a research paper, you can have like 100 way of breaking down this problem. I can have a researcher agent at first and then connect it to a writer agent, and then I don't know, maybe there's a last agent, but you can like switch things around. You can have like I don't know, multiple research agent and then connect it to the same writer agent. So yeah, I think there's some also some efforts about how to do agent architecture search, which I think is pretty cool. And also, like I could imagine that could be pretty hard because with the different components going around, and I think essentially people want to disentangle the effect of the structure to the final results. But there's certain challenge in this because the agent could just there's like a certain high randomness of these agents and they could just output different results every time. Or yeah, I mean, like it could be also about not because of the structure, might be just like some certain agents they are not compatible together. So I think it's a really challenging problem, but also important, like what you said, maybe people initially want to construct a workflow but they have no idea how to do that. Yeah.
yeah, oh yeah, I think that's perfect. I think, and then to another, yeah, I love that point of how do you construct it. I'm learning so much that I'm trying to like even process my next question. But so there was this other, so when you present this idea of you have a query and you use it to retrieve a workflow, I think that makes a ton of sense. Like you have this general agent that does all sorts of things, and like now you're asking it to query your courses catalog, and it's done that a few times. So it can retrieve that particular workflow of how it's navigated the courses database in the past. But then there's been this other camp of like few shot examples, and like maybe I should retrieve a similar few shot example for in context learning. And it seems like that like KNN few shot example camp is like maybe not winning as much as this
Yeah.
retrieve the workflow.
Yes, yeah. I think the it's kind of weird because we also tried that in the in the avatar paper because we also store like this experience uh library, and then for some unknown testing query we just retrieve the one that's most relevant. But I think it doesn't work well because um it's really hard. I think it's about the generalization of those solutions, and some of the solutions are just very specific to an instance. And we see solutions about like if you have like a action sequence trying to solve the Nike shoes problem, and you can see in the workflow maybe the agent just roll some hard coded stuff like if Nike in the story, then blah blah blah, and it's really been a headache about like how to have a more generalizable. And I think it's also not about. So I think we should really like in those solutions we really want to go from a certain observation in a like very instant specific observation to pattern or like more insightful guidance for those agents. And I think that's a certain thing that we want to improve, like this few shot and in context learning. I think that would be the key to get those agents to work well.
Yeah, amazing. And that comes back to that what you opened by describing about like the large batch sizes used in contrastive learning, and yeah, I think that yeah, it's such an interesting idea. So many amazing ideas and all this. Sure, so I think this is amazing coverage of Stark and then Avatar and then all this agent design and combat AI systems. I'd love to ask just about kind of like like broadly what future directions excite you the most, kind of like maybe what's next for the Avatar or Stark, and I understand also Graph Metro, just yeah, just like kind of what's next for you.
Yeah, yeah. So I think the maybe two directions excites me most. One is the compound AI system, compound agent system, that we we did have some like this initial exploration, and this is very hard task, I would say, and sometimes it's just very hard to find. I think in the single agent is relatively simple. We are trying to find the correlation between the this action to the final performance. Oh, sorry, actually the prompt to the final performance, and then we are just doing this like exploration. But for the component agent system, there's so much like intermediate output, and sometimes they are just not improving. Some components are just not gonna bring too much performance improvement, and we are trying to be like more have a more like selective mindset, just to trying to look maybe some agents they are more crucial to the final performance, and we are trying to like improve that. But yeah, this is still ongoing, and I think this is really an open question, and I think typically there are also like previous efforts trying to correct the good trajectories and then do like supervised fine tuning for each agent. I think that certainly works could work quite well, but we are trying to go beyond that. So maybe the user just doesn't have too much data, right? Maybe you just have like 10 queries and then you have like know the answers for these 10 queries. But those data are not gonna be good enough to do supervised fine tuning or reinforcement learning. So we really want to again leverage the reasoning capability of LMs and know like how to optimize in a like more complex pipeline. So I think that's one direction, and the second direction I think is towards more like human-centered LM, and I think it's really like typically ignored by a lot of research field as well. I think the basic setup is that after with like those ILHF and like those powerful reinforcement learning algorithms, the LMs can answer problems really well. They are very good responders. They take instructions well. But still, I think towards, AGI, there's still one big step lag behind, which is how to make the machine and the human collaborate better. So, for example, if I ask LM, I ask ChatGPT about like, I can say, oh, I feel uncomfortable. I had a headache, and it would just give me like 10 different kind of symptoms that I could have, which I may or may not understand or may not applicable to me. But imagine like a patient goes to a like hospital, and the doctor would ask their symptom, oh, like how long has the symptom been, or like, yeah, do you like exercise a lot yesterday, and the things like that. So I think there's a lack of interaction, and in the LNs nowadays to be like more I think user centric and multi-turn aware. So we actually, yeah, I think this is relevant to one of our recent publication as well called collab LLM, which is actually my internship project at Microsoft, and we are actually trying to build a more like interactive LM that can understand your intents across like multiple turns of conversation. And I think this excites me a lot, and I really had great fun doing that project as well. Yeah, and I think it's also a like very interesting perspective about whether we are trying to make an L more interactive, more like collaborative, and in the agent society, maybe there's a certain benefit that, just like a teamwork, sometimes we expect some people to be more active, like drive the team energy, and then some people just like do the task as what they told. And I think it's very interesting. Maybe in the agent society, maybe in this like multi-agent, there's a certain implicit properties that we can tune in this agent society that can make them like just more productive. And yeah, I think that would be amazing to see.
Yeah, amazing. Shirley, so many amazing ideas, and yeah, just how the future directions things evolve. I think I've been like on the I've been hearing about this like more human in the loop, and I think hearing it from you, I'm definitely more interested in it myself. And then yeah, these agent societies, I think it's such a future looking concept, but definitely something that seems to be here is yeah, treating like agents like people and integrating them into these systems is also amazing. Shirley, thank you so much for joining the Weaviate Podcast. It's been amazing, yeah, learning about all these things. Thank you so much.
Thanks so much.